about gas pressure. And the first question asks, what is a vacuum? What is a vacuum? So a vacuum is just a region in space where air has been pumped out. Okay, so if you remove all the air, then you're left with a vacuum. So a region where air has been removed. Let's say if you remove the air, then you are left without, or you're left with a vacuum rather. Let's highlight this. Let's make this a little bit less opaque. So vacuum, let's change the color a little bit less opaque. So that's vacuum. This is interesting. Right, so what's the next question? The next question is, there is pressure on the inside and outside of this plastic bottle. Let's use the pointer, guys. There is pressure on the inside and the outside of this plastic bottle. A. What is causing the pressure? Explain as fully as you can. What can you say about the size of the pressure inside? Let's make this smaller. And outside the bottle. Okay, so let's see. So there is a bottle. Now on this bottle, the top is open. Okay, there is pressure on the outside and there is pressure on the inside. Okay, so the pressure on both the inside and the outside is being caused by air. Let's make that darker. It's being caused by air particles. Okay, so the air particles are bombarding the outside and the inside of the bottle. What can you say about the size of the pressure inside and outside the bottle? So the pressure inside and out, because it's open at the top, the pressure is equal. Okay, equal pressure inside and equal pressure outside, which keeps the bottle intact. Okay, even if you do close the bottle as it is now, okay, the air inside remains the same and the air outside, the pressure still remains the same. So the bottle does not collapse or get bigger, stays the same. Okay, now the air being sucked out of this bottle. Okay, what will happen to the bottle as more and more air is taken out? Okay, so now you've got a pump. You've got a pump here, and the pump is taking air out. Okay, so air out, which means the amount of air inside is reducing. So there is less air inside here, which means less pressure. Okay, so if there's less pressure, then it means there is now more pressure, okay, on the outside as compared to the inside. So more pressure on the outside. Okay, it's more compared to the inside, but the pressure outside has remained the same. Okay, it has remained the same because it is still the same amount of air on the outside. But what's happened is, because we've reduced on the inside, okay, it means when you compare the inside to the outside, then the inside pressure has reduced. Okay, so what we expect to happen is that the pressure on the outside is going to push inwards. Okay, let's see what the question actually asks. Why will this happen? I think I've explained that. Okay, because of the amount of, so less air pressure on the, less air on the inside, less particles hitting this the inside of the container or bombarding the inside of the container, so less pressure. Okay, on the outside, however, there's still the same amount of air and the bombardment is still the same, and so you've still got the same atmospheric pressure on the outside. Okay, that's that. Now you can use a piece of card to make a lid for a glass full of water. The lid will keep the water in even if the glass is upside down. If you try this at home, do it over the sink. What makes the card stay when the glass is upside down? Okay, so there is atmospheric pressure on the lid, on the piece of paper, on the card. Okay, there's going to be, already there is atmospheric pressure pushing against it. When you put it upside down, the pressure is still there. But there's also the capillary action of the water particles on the card from the inside. Okay, this trick does not work if the glass is not completely full of water. Try to explain why. So if it's not full of water, it means that there is a gap. Okay, and water is able to fill that gap, and when it fills that gap, it's able to push the lid out. Okay, liquids are useful in car braking systems. When the brake pedal is pressed, okay, there is a brake pedal right here. When the brake pedal is pressed, let's make this smaller. Okay, and then we can read along. When the brake pedal is pressed, some brake fluid is pushed along the brake pipe. The brake pads are pushed onto part of the wheel, making the car slow down. This would not work if the liquid could be squashed. Why is a liquid useful for making brakes work? Okay, because the liquid is able to transmit the pressure from the foot pedal to the rest of the pipe where the liquid is. Okay, so the liquid is just transmitting the pressure, which means if you press down on the foot pedal, then that pressure is transmitted through the master cylinder, which is here, and the rest of the pipes to the wheels where you've got the brake pads. They get squashed or pushed against part of the wheel, and when they do that, let me just blow that up a little bit. Okay, so if you look here, you've got the brake fluid coming through here, pressing against these brake pads, push against the cylinder. Okay, and the cylinder is attached to the wheel, so that stops the car. Okay, that stops the car. Right, let's see if there's another question. But why could you not use a gas in the brake pipes? Well, because you can compress a gas. That's why you can compress it. If you can compress it, it means it does not transmit the pressure than if you could not compress. So you cannot compress a liquid. That's why you're able to. That's why it's able to transmit the pressure. Explain as full as you can using ideas about particles. Well, the particles in a gas have spaces between them. So when you compress it, the spaces become less. Okay, because the particles are moving closer together. Okay, but in a liquid, the particles are closer together, and it's more difficult to to reduce the space between them. Okay, so that's all the questions answered for this one. If there is any misunderstanding or confusion, please let me know in the comments and I will make another video to explain any misunderstandings. Okay, so remember, the questions are more important than the answers, so keep asking the questions and I'll keep answering them. Thank you.